Syllogs. This is an extremely important topic for a student, and anything less than 100% accuracy is not to be accepted in this topic. The topic is important as at least 2 to 5 questions are expected from this topic in most of the aptitude tests. In this session, we will first discuss 2 important components of syllogism, premise and conclusion. We will also discuss the concept to be used to solve the questions, which is a 3-step approach. We will then apply the concepts learned on practice questions. First, premise. Let us start with a simple question. What do you understand by a premise? Let me give you an example. It is raining and therefore I will not step out of the house. This example has 2 parts. Premise, it is raining, and conclusion. A premise is the reason that we use to decide or infer or deduce something, or the because part is the premise. What do you understand by conclusion? In the same example, therefore I will not step out of the house is the conclusion. The final deduction that we make is the conclusion. In simple words, the because part is the premise and the therefore part is the conclusion. Now I'll give you one more example and you have to tell me what is the premise in this sentence. I do not play chess as there is no physical activity involved in the game. Yes, as there is no physical activity involved in the game is the premise because it is the reason for me to not play chess. I do not play chess is the conclusion. What is tested under this topic? Students are given some statements or premises and are given some conclusions. The task is to identify the correct conclusions. We will explain that in some time. First, let us try to understand the different premises used in this topic. There are mainly 4 statements or premises given. Let us look at them one by one. First, all A are B. This premise or statement is open to 2 interpretations or meanings. In interpretation 1, all the B's are also A. In interpretation 2, there are some B's that are not A. Let us now discuss an example. Let us say that it is a fact, statement or premise given, that all politicians are corrupt. In this example, politicians are A and corrupt is B. If we know that Ramesh is a politician, what they can conclude about Ramesh? You know for 100% that he will be corrupt. So basically, from the statements, all politicians are corrupt and Ramesh is a politician, we can make a conclusion that Ramesh definitely is a corrupt. You may look at both the interpretations. If Ramesh is a politician, A, he will have to be corrupt, B. Now let us say that we know Suresh is corrupt or that Suresh is B. What do you think can we conclude about Suresh? Look at interpretation 1. If we use this possible meaning, we can conclude that he is a politician as all B, corrupt, are also A, politicians. But if we look at interpretation 2, we cannot say with 100% guarantee that Suresh is a politician because he could be an engineer and a corrupt engineer. In other words, he could fall out of the circle that denotes A. There are 2 possibilities when it comes to B. Corrupt in this case, as the statement, all politicians are corrupt, has 2 possible meanings. And therefore, we cannot conclude that Suresh is a politician. Suresh may be a politician is a correct conclusion. While solving the question, we have to take care of all the possible meanings. Some A are B. What comes to your mind if you see this statement? Some A are B. What comes to our mind is that some A are not B. Let me give you an example. If I say some students are smart in a class, automatically most of us will think some students are not smart. While this is okay in our day-to-day language, this conclusion is incorrect in logic. This premise is a tricky one because this statement, or premise is open to 4 interpretations or meanings. Some A are not B is definitely a possibility, but not a conclusion. Some A are B could also mean all A are B, and therefore some A are B is open to 4 interpretations or meanings. In interpretation 1, some A are not B and some B are not A. The shaded portion is given and the other portion is assumed. In interpretation 2, some A are not B but all B are A. The shaded portion is given to us and the other portion is assumed. In interpretation 3, all A are B but some B are not A. Here it is assumed that the other half is also B. In interpretation 4, all A are B and all B are A. Here also it is assumed that the other half is also B. Let me explain with an example. If a teacher says some students are smart, the reality could be that all students are smart. He may not say all students are smart for 2 reasons. First, he genuinely is not aware of the smartness level of the remaining students in the class. Second, he intentionally does not say all because he wants to have a feeling of competition among the students. To make the conclusion, some students are not smart would not be correct. To clarify, you must ask the teacher what he means about the remaining students. Let me give you a statement. Some students are smart and that Ramesh is a student. What all possible interpretations can we make from these statements? Ramesh could fall in interpretation 1 or 2, and in the assumed part, it would mean that Ramesh is not smart. If Ramesh falls in interpretation 1 or 2, but in the shaded portion, then it will mean that Ramesh is smart. If Ramesh falls in 3rd or 4th interpretation, it would mean that Ramesh is smart. As a student, you must be aware of these possible interpretations once you see this statement. Some A are B could also mean all A are B. Third, no A are B. This statement has only one interpretation. Example, if the statement given is no student is smart, and now we know that Mahesh is a student, we will know with 100% clarity that Mahesh is not smart. Also, let's say we know that Kunal is smart. We will know that Kunal is not a student. Some A are not B. Just like in statement 2, if we read this statement, we automatically conclude that some A are B, while some A are B is definitely a possibility. It is not a conclusion. Some A are not B could also mean no A are B, and therefore some A are not B is open to 3 interpretations or meanings. If I say some students are not smart in this class, that could also mean that no student is smart. It is possible that I know only 2 students out of the students present in the class and they are not smart. I have no idea about the smartness level of others present, and therefore I said some are not smart. Now it is quite possible that after my interaction with all the students I realized that in reality no student is smart. In interpretation 1, some A are not B and some B are not A. The shaded portion is given and the other half is assumed. In interpretation 2, some A are not B and all B are A. The shaded portion is given and the other half is assumed. In interpretation 3, no A is B and no B is A. Here it is assumed that the other half of A is also not B. So if there is a statement, some cakes, that is A, are not sweet, that is B, and we know that Purushottam is eating a cake. Now if this cake A falls in the shaded portion in interpretation 1 and 2, the cake will not be sweet. If it falls in 1 and 2 but not in the shaded portion, it means it will be sweet. If it falls in third interpretation, then this cake A will not be sweet. B and anything that is sweet can never be this cake. This is how a question looks like in this topic. We are given some premises, 2 in this case, followed by a number of conclusions. We have to decide how many conclusions are valid if the statements given to us are facts. If the given question using the 2 statements or premises, we can conclude 1. That is, all students are men, but cannot conclude 2. Some men are not students. Then we will mark A. If we can conclude 2, that is, some men are not students, but cannot conclude 1, that is, all students are men, then we will mark B. If we can draw both the conclusions from the given statements, then we will mark C. If we cannot make any conclusion, then we will mark D. Our task is to use 2 statements or premises and answer whether the given 2 conclusions are valid or not. The students cannot violate the statements given. For example, all men are girls, we know has 2 possible interpretations. Using this statement, if we say that no girl is a man, we will violate the fact given to us. If we say all girls are men, that is a possibility. And also, if we say that some girls are not men, even that is a possibility. The students cannot violate the statements given. For example, all men are girls. We know that has 2 possible interpretations. Figure 1 and Figure 2 are correct interpretation. Figure 3, however, violates the premise, as here there are some men who are not girls. Okay then, try to solve the question. While solving such questions, most students fall in a trap. Let us discuss the potential trap. Using premise 1, all men are girls, we can draw a figure like this. Using statement 2, some girls are students, we can get a diagram like. In this diagram, it looks like we can draw the conclusion that all students are men, right? Wrong. While all students are men is definitely a possibility, it is not a conclusion. Using this figure, students may say that the conclusion is valid as all students are men, and we have not violated any of the 2 statements given to us. This is a trap I was referring to. To avoid falling in the trap, always follow the 3-step approach. 3 steps approach to crack syllogisms. Step 1. Go directly to the conclusion and work the counter for that. If X says that all the houses of his locality are of yellow color and you were to prove him wrong, what will you do? To prove him wrong, you will find one? Yes, only one house that is not of yellow color. If you can get one of houses that is not of yellow color, you would have proved him wrong, and therefore his conclusion will be invalid. Similarly, in the conclusion, all students are men, the counter argument will be at least one student is not a man. Now, this becomes our task. If we can prove our counter argument, it means the given conclusion is incorrect. We have to use both the premises, do not violate them, and then try to prove the counter. Before we proceed with the second step, let us get the concepts on counter of the conclusion, that is, the first step clear. There are 4 conclusions that are checked in a question. Let us try to understand the counter of all the possible conclusions. Conclusion: all A are B, and the counter: some A are not B. Conclusion: some A are B, and the counter: no A is B. Conclusion: no A is B. Counter: some A are B. Conclusion: some A are not B. And the counter: all A are B. So basically, counter of all is sum and counter of positive is negative. Now let us continue with the three-step approach. The first step is to know the counter of the given conclusion. Step 2. Use premise 1 and draw a simple Venn diagram. All men are girls. Now the final step is the step 3. Step 3. Use the second premise and try to accomplish your task. That is, prove at least one student is not a man. Second premise. Some girls are students. As you can see that without violating any of the premises, we have proved the counter argument, and therefore the conclusion that all students are men is not correct. So basically, two diagrams could be made using the two statements given. Diagram 1. This shows the possibility that students are men, and the second diagram which we drew, this shows that no man is a student. Please note that even this is a possibility and not a conclusion. Our task is only to prove the counter of a given conclusion and not the conclusion. If we can prove the counter, the conclusion is not correct. If we cannot prove the counter of the conclusion, it is correct. Let us revise the three steps. Can you recall the step 1? Figure out the counter of the conclusion. Can you recall step 2? Draw a simple diagram using the first premise. Can you recall step 3? Use premise 2 on step 2 and prove the counter. If you are able to prove the counter, the conclusion is invalid. Otherwise, it is valid. Let us see whether in the same question, conclusion 2 is valid or invalid. Try to solve this on your own before we proceed. Step 2 is use premise 1 and draw the simple diagram. So, all men are girls could be drawn like. The final step is to use premise 2 on step 2 to try to prove the counter. Using premise 2, some girls are students, we can draw a diagram like this. Since we have proven the counter that all men are girls without violating the conclusion, even this conclusion is invalid. Now that we have proven both the conclusions as invalid, the correct choice is D. Before we proceed with the second step, let us get the concepts on counter of the conclusion, that is, the first step clear. There are 4 conclusions that are checked in a question. Let us try to understand the counter of all the possible conclusions. Conclusion: all A are B, and the counter: some A are not B. Conclusion: some A are B, and the counter: no A is B. Conclusion: no A is B. Counter: some A are B. Conclusion: some A are not B. And the counter: all A are B. So basically, counter of all is sum and counter of positive is negative. Let us practice some questions now. First, conclusion 1 is some books are pencils. Let us apply 3-step approach on conclusion 1. Step 1. Counter of conclusion 1. Some books are pencil is no book is a pencil. Step 2. Use premise 1. All books are papers to draw a simple diagram. Step 3. Use premise 2 on step 2 to prove the counter, that is, no book is a pencil. Using premise 2, some papers are pencils, we can get the final diagram as. Since we can prove the counter conclusion 1 is invalid. Now let's apply the same approach on conclusion 2. Step 1. Counter of conclusion all pencils are books is Some pencils are not books. Step 2. Use premise 1 to draw a simple diagram. Step 3. Use premise 2 on step 2 to prove the counter, that is, some pencils are not books. Since we can prove the counter of this conclusion, also even this conclusion is invalid, our answer is therefore D. Please note that we could have proved the counter using the previous diagram itself, so there was no need to draw this diagram. Step 1. Counter of conclusion no safe is rash is some safe is rash. Step 2. Use premise 1 all rash are driving to draw a simple diagram. Step 3. Use premise 2 on step 2 to get the counter some safe is rash. Since we can prove the counter of this conclusion, also even this conclusion is invalid, our answer is therefore D. Step 1. Counter of conclusion. Some actors are arrogant is no actor is arrogant. Step 2. Use premise 1 some actors are stars to draw a simple diagram. Step 3. Use premise 2 some stars are arrogant on step 2 to prove the counter no actor is arrogant. Since we can prove the counter, this conclusion is invalid. On conclusion 2, step 1, counter of conclusion no actor is arrogant is some actor is arrogant. Step 2, use premise 1 some actors are stars to draw a simple diagram. Step 3, use premise 2 some stars are arrogant on step 2 to prove the counter some actor is arrogant. Since we can prove the counter of this conclusion also, even this conclusion is invalid. Our answer is therefore D. For conclusion 1, step 1, counter of conclusion all coins are letters is some coins are not letters. Step 2, use premise 1 all coins are stamps to draw a simple diagram. Step 3. Use premise 2 all stamps are letters on step 2 to prove the counter some coins are not letters. Since we cannot prove the counter, this conclusion is valid. On conclusion 2, step 1, counter of conclusion all letters are coins is some letters are not coins. Using the previous diagram itself, we can prove the counter. Hence, no need to make a fresh diagram. Since we can prove the counter of the conclusion, this conclusion is invalid. So conclusion 1 is valid and conclusion 2 is invalid. Hence, our answer is A. For conclusion 1, step 1. Counter of conclusion 1. Some bats are stumps is no bat is a stump. Step 2. Use premise 1. Some bats are balls to draw a simple diagram. Step 3. Use premise 2. No ball is a stump. On step 2 to prove the counter. No bat is a stump. Since we can prove the counter, this conclusion is invalid. For conclusion 2, step 1, counter of conclusion some bats are not stumps is all bats are stumps. Step 2, use premise 1, some bats are balls to draw a simple diagram. Step 3, use premise 2, no ball is a stump to prove counter all bats are stumps. Since we cannot prove the counter, this conclusion is valid. As conclusion 1 is invalid, and conclusion 2 is valid, the correct answer choice is B.